Well, hello and welcome to the next edition of QTalks, an online series of conversations about the future of water powered by KTM. So these 30-minute bite-sized, digestible live discussions are designed to be shorter, punchier, engaging discussions that you can enjoy live or even on demand with a nice cup of tea or a coffee break later on. So the topics vary from digital twins through to investment to US water security and much, much more. My name is Tom Freyberg. I'm an environmental journalist and content creator specializing in water, and I'll be your host for the next 30 minutes. So today we are addressing the topic of water quality. It's no doubt one of the most important issues in the industry, and also perhaps one of the most politically charged and sensitive topics as well. And often we hear about the impacts of climate change on water availability, whether there's too much or too little. But also, what about the impacts of climate change on water availability in terms of the quality as well? So today we're joined by representatives from both sides of the pond, from the North America as well as Europe. We're pleased to be joined by Heather Collins, who is the Water Treatment Manager at the Metropolitan Water District of Southern California. Heather, great to see you. Thanks for joining us.
Good to see you, Tom. Thanks.
Jan Rieberg, who is the Principal Scientific Researcher at KWR Water Cycle Research in the Netherlands.
Yeah, thank you for having me. Looking forward to this.
And last but not least, we're joined back over the Atlantic by Andrew DeGraca, who is the Water Quality Division Director at the San Francisco Public Utilities Commission. Andrew, great to see you and connect, and thanks for joining us.
Thank you. It's very nice to be here.
Great stuff. So we have a full house, and throughout the session, please feel free, as usual, for those of you who have attended QTalks before, to share your thoughts, your questions, your opinions, whether you agree, disagree, and we will try and get through as many as possible. So really to get going, because we've got a fair amount to sort of get through in the next 30 minutes, it'd be great just to hear from our panelists to give some, when it comes to water quality, just to kind of elevator pitch on the context of the water treatment infrastructure and some of the water sources you're dealing with within your respective utility. So maybe, Heather, let's come to you first, please, on that one.
Sure. Thanks, Tom. So for Metropolitan Water District, we are a water wholesaler for Southern California. We service 19 million people in the greater reaches of Southern California. We mainly get our water supply from two big buckets. One, we are a state water contractor, which takes water from Northern California's runoff and rivers and lakes, and that's conveyed down to Southern California through the state project. And then also we own and operate the Colorado River aqueduct system that takes water in from the Colorado River watershed through Lake Havasu, and we bring that in to our basins. We have a network of over 830 pipelines and tunnels, which are gravity fed once they're pumped to the mountain point. And we have 5 treatment plants and a lot of hydroelectric and pump facilities around the basin. With those two sources, obviously drought really plays into the availability and the allocation of the state water that's coming from the north. Right now we are in all of the state is in a drought. So we are minimized on that supply of water. So we're balancing that with storage programs that we have, with taking waters from local storage in the basin, and also bringing in the water that we can from Colorado and up north. So it's a very balanced dance of how we build the reliability for our region. And so obviously drought, climate change, wildfires, impacts, all play into water quality that we take into the facilities.
Great stuff. Thank you, Heather. And we've heard in previous episodes of QTalks about the current water stress on the Colorado River Basin as well. So thank you for that. Let's jump to you then, Jan, in terms of KWR and working with the Dutch utilities. Give us a very quick snapshot of perhaps the Dutch water network and why, based on a previous conversation, that's perhaps a little bit unique compared to others around the world as well.
Okay. Thank you, Tom. Well, the Netherlands is a small country in Europe. It's near the coast of the North Sea, and actually, we are very densely populated in a very heavily industrialized area. We have about 17.5 million inhabitants, and from well, you could say 75 years ago, we are very aware of water quality. The Netherlands being for one third below sea level always made us very aware of water and the strength of the quality, you could say, with a very high ambition as well. If you're looking into the water sources, you can see two phases, if you like. The part that is above the seawater level, mainly uses groundwater, which is a very well protected source. And the part that is below sea level, it's one third of the country, which is the most heavily populated as well. About 10 million people live there. And they are served by surface water from rivers, the River Rhine and the River Meuse, both going through a very heavily industrialized area. So you could say it's kind of an open sewer that we make water of, which made us quality aware and to such a high ambition even that we distribute water without a chlorine residual, without a residual disinfectant. The discovery of THMs, if you like, is Dutch originated. In 1976, it was discovered, and from that point on, the water companies decided to distribute water without or as much as possible, without a chlorine residual, and it set some boundaries to the network as well. Again, this quality awareness is, well, it's not a trick. It is an attitude that is now lasting for 75 years, and that results in a very careful procedures in constructing and making networks, resulting in a network nowadays with about 120,000 kilometers, 19,000 miles or something, that has a leakage percentage of 5% or even less. Well, one of the things is that the construction needs to be very careful, and that gets you to a quality level. Well, that is what we actually have at the moment. And of course, the threats we encounter with micropollutants, microplastics, other industrials, medicine residuals in source water, they are all of concern. But as we are used to extensive treatment, well, we will have to cope with that as well.
Yeah, and thank you very much. I think it's great to hear about the unique position of the Netherlands being below sea level, having to be the masters of resilience, but also building a network that's chlorine free. Thank you very much. Finally, then, very quickly, Andrew, in terms of the San Francisco perception, if you could please give us a bit of context on your treatment infrastructure and the water sources as well.
Okay. San Francisco Public Utilities is a water, wastewater, and power utility. On the water side, we serve about 3 million people. 2/3 of that is for wholesale customers. Our major source of supply is the Hetch Hetchy Reservoir, which is in National Park. It's of such exceptional quality that we have a filtration, so we just provide UV treatment and some chlorine disinfection. We also have local reservoirs and 2 treatment plants. Those are typical conventional treatment plants. We're adding ozone to one. We have ozone to the other one for a couple of decades. We also have a very small groundwater supply that we're developing, about 1% of our total. We hope to increase that over 2 years.
Fantastic. Thank you, Andrew. Well, we'll hear more about your kind of treatment techniques and innovations, particularly around digital a bit later on. But we want to kind of jump straight in on the topic of water quality and how I think the respective utilities and KWR see this in relation to kind of leakage. And perhaps it's a bit of a politically charged question or statement to lead with. But water quality continues to be the poorer cousin of leakage. Discussed. We'd love to just get your thoughts on how you're seeing that and really how it's changing with new investment coming in. Maybe we'll start with you, Heather, on that one, please.
Well, with the infrastructure bill that was passed here in North America with the US, that's really the most largest infusion of public funding for infrastructure for water and wastewater that we've seen in history here. And that'll really help, I think, to go through clean water and safe drinking water funds that are enacted with the states, really help to address some of the issues that have been plaguing water systems. Certainly, there are a number of different constituents that we watch for. Everything from groundwater constituents that impede the ability for groundwater basins to be used for storage and banking and replenishment, obviously, then to things that are for agriculture that are carried through our surface supplies and runoffs, and such. So we're very interested and very supportive of that funding. There's a lot of funding that's earmarked for PFAS constituents. We're working actively with our member agencies, our board, to look at funding opportunities for ensuring the source water quality for our lakes and our sources of supply. But then also we work with our member agencies to ensure that they can leverage their local supplies, which inevitably helps us save water that we're importing. So it's quite a balance. So that's our interest in the funding that's there, and that will also help. We think we're in diversifying supplies. We're also looking at recycled water utilization across the region, and there's other funding that is potentially available to build a more drought resilient supply for our area. So water all is one, whether it's groundwater, surface water, recycled water, wastewater, all that. So when it comes together, we're most interested in ensuring source water quality first and ultimate water quality for our constituents. So I'll turn it back to you.
Encouraging to see, I think there's about 10 billion allocated for water companies in regards to just PFAS and water quality as part of, as you mentioned, the once in a lifetime infrastructure bill. So it's encouraging to see a allocated budget. I think it'll be a question to see how far that can be stretched. But let's come on to you then, Jan. In terms of you've had a healthy career in terms of looking at the water network. So would you say, compared to leakage, that water quality has remained the poorer cousin, or do you think it's getting more attention as the years have gone on from your time there?
Yeah, well, as I told you, leakage is not really an issue in the Netherlands because it's only 5% or even lower in certain areas, and that we are very aware of water quality. And you could say that they are interrelated. So you get it. Well, network is the symptom of a dysfunctioning network, and the solution is to upgrade the network again so it doesn't leak. You can try to put band-aids on each and every leak that you find, but you will do that eternally, and replacing it with a network that is very carefully made gets you to a situation that there is no leakage. And a very carefully made network, as is necessary to be able to provide high quality drinking water without a chlorine residual, so they are kind of connected to each other, means that that it takes a long time to actually achieve that. I could say in the Netherlands it took us 40, 50, maybe even 75 years to get to this point. And if you see at the total way of approaching the network, there is a whole system of teaching technicians on approval of technicians before they are allowed to work in the network. So it's always a long-term consideration, and each and every investment that you want to make, you have to see on this time scale of 50 to 75 years. So the actual moment of investment is only minor to the whole lifetime support. And as you said, Tom, earlier, you can calculate the difference of 40-year or 30% leakage as opposed to 100 years of 5% leakage. Even that is a sum that you can make, but it does take a long-term view on how to design, make, and operate the network, and try to manage that on a full cost recovery with the tariffs that you charge to your customers. But again, something with a lifetime expectancy of 50 to 100 years, and also your financing structure should be on that same time scale.
Yeah, and thank you.
Well, the example of the Netherlands shows. Yeah. Sorry.
I think the 5% leakage rate is perhaps enviable around the world. It's it's a fantastic record to be set. And like I said, in terms of thinking for the 100-year life cycle of the pipeline, the network, it's an interesting way of coming at it. But let's go back across the Atlantic to Andrew then, in terms of how you're viewing leakage versus quality in terms of investment priorities, and really whether that's changed over the years, given the perhaps increased attention around contaminants of increasing concern.
To a great extent, we're living on our laurels. The CDC stated that both disinfection and fluoridation were the two of the 10 most significant public health interventions in the 20th century. We are pretty comfortable in the water we deliver. I think customers are generally happy. If they're not, they use bottled water or they use point of use treatment devices. I think it's going to take some event like a crypto event in Milwaukee in 1993 that's going to force a major change. I think there's some local, particularly state level concerns. So we're starting to see microplastics in California, PFAS in various states. So I think it's going to slowly change, but I just don't think there's a big driver yet to force a significant change where water quality is more focus.
Really interesting you mentioned about specific states perhaps moving a bit quicker. So that leads on really nicely onto the next question about regulatory drivers, because obviously regulation drives change, especially when it comes to perhaps additional treatment needed for contaminants of emerging concern. So perhaps you can maybe comment on that, Andrew, in terms of whether the regulatory drivers are moving quick enough, and whether kind of state by state taking it into their own hands is the way to go.
I think the quick answer is no, we're not moving fast enough. We have states take the lead for EPA. I think that indicates a problem. I think even some localities could go farther than that. One of the big issues is that when we develop regulations, we need to have sound science. And I think that's the biggest problem that we have right now, is that we don't have a research pipeline that can look at treatment, the current health effects, cost benefit, so that we can make good informed decisions. A lot of these regulations are going to cost billions of dollars, so we need to make sure that we're spending public money wisely. So what I'd like to see is EPA get the funding, have focused management, and really start leading the regulatory effort. And some of the stuff takes many, many years, develop methods. So if we have that pipeline developed now, I think we'll be in better shape. But right now, we're very reactive in terms of developing regulations. Something happens, and we're rushing around trying to develop methods. So we've got to change the way we do business.
That's a really good point. And so do you think the allocated budget from the infrastructure bill is enough to stimulate that change needed?
Honestly, no. I think unless there's a major driver, we're not going to change. The last time we had major regulatory changes was in the 1996 Safe Drinking Water Amendment. So it's been decades. Before then, there was the 1974 original Safe Drinking Water Act, and 1986 Safe Drinking Water Amendment. So we have to do something different, and it's going to take some leadership to make that change.
Okay, interesting. Appreciate the frank viewpoint. Maybe Heather, you can chime in then in response to kind of Andrew's perspective in terms
Certainly.
of on the regulatory drivers and what's really needed to push that forward.
Certainly. To add to what Andrew had already said, there's definitely a need for a synergistic assessment across all industry sectors. And when I say that, I mean, there are agricultural overlays with the water sector, there are pharmaceutical overlays with the water sector that are not necessarily looking at a cohesive research to assess the impacts of those other sectors' business practices and its impacts on water sources and supplies. So we definitely need some type of different research agenda. There are aspects within each state that state entities are trying to advocate for legislation to look at, helping the state programs build these types of programs to look at and prioritize and help them with identifying, the emerging constituents of concern, rather than them deciding what needs to be looked at. Having a forum that looks at all areas of those state kind of entities that oversee, the pollution, the distribution of water, the source management. They have been doing, in their own groupings, but then homogenize that across the enterprise. We're better together, so let's learn from what each other's doing. It's been too siloed in the past, and when you look back, I kind of pull an experience from a few decades ago with MTBE, when analytical labs were running samples for oil and gas, and then subsequently they're running samples for water systems, and they found similar peaks to what they had identified in oil and gas, and that brought the forefront of discovery into water supply of these constituents. And so that took an analytical lab, a commercial lab, to do that. It shouldn't be found at that level. There should be things when they're developing new products, looking at different indicators or surrogates or things when we're assessing product approvals for fire retardants and other chemicals that are being, developed, new pharmaceuticals. We should understand those effects and impacts on the environment before they're out in the marketplace.
100%. So more joined up thinking between industries, ultimately to help identify and stop any of those contaminants or constituents of emerging concern getting into the environment in the first place. Great stuff. Well, thanks for that perspective, Heather. So then we are rushing on with the time. So we really want to kind of find out, and the title of the session is around digital innovation and disruption and the role that plays within water quality monitoring. So maybe we'll come to Jan from KWR in terms of where you see increased sensors, increased data, in terms of giving utilities and water companies actionable data when it comes to water quality treatment. Where have you seen any sort of recent innovation from KWR's research on that?
Recent innovations, of course, the availability of sensors and measuring equipment in the abundance that we see in the last couple of years is impressive. And so the question of optimizing the places and locations where you want to put those sensors is, of course, very actual in this case. So the optimization software for those kind of locations of sensors, etc., we are developing in a large scale. But on the other hand, I always want to connect the problem that you want to discover, or the problem that you want to describe, to the type of measuring or the type of sensoring that you do. So, for instance, if you're looking at the condition of a network, again, which has a time scale of 50 to 100 years, you don't need a minute-based sensor data or whatever data that you want. And on the other hand, also water quality, it's good to help you understand what is going on. So that is the goal of research, or the goal of analysis of what's going on. But if you are sensoring or monitoring with the goal to influence the operation of the network, then the possibilities that you have to actually direct flows, or to manage residence time, or to manage temperature or water quality, are also limited. So you can know a lot of you can have a lot of sensor data that helps you to understand what is happening, which is good from a scientific point of view and for the long-term measurements. But for the short term, if you cannot do anything, what's the use of those kind of data as well? So you have to define what you do towards what you need to have. So, for instance, 30 years ago, we had 3 sensors for turbidity and pH, and that is what we used on several locations in the network to understand what is happening. So 3 weeks of data was enough to get to the process and to see what is happening, and then try to formulate measures that you can actually manage these processes or influence these processes. 3 weeks of data measuring was enough because the other 3 weeks or the rest of the year is more or less the same, which
Right,
doesn't give you any.
unless you're changing the treatment infrastructure,
No,
it's not going to change as much within those 3 week periods. Yeah, because we
yeah,
often hear
that's right.
about the need for real time sensors, real time data, but actually your argument is unless you actually need that to be in real time, perhaps that's a step too far. But Jan,
Well,
thank you
you
very
have to
much.
have you have to be able to make use of those data. You can generate generic sensor and data, but what kind of parameters are you looking for? What kind of measuring are you doing, and what can you do with it?
Fantastic. Thank you, Jan. So, Heather, in terms of then the use of digital innovations on water quality, you're doing quite an interesting project involving satellite-based data. Can you tell us about that and some of the other innovations you're seeing on this area?
Certainly. Thanks, Tom. For Metropolitan, we've been using scuba diving for monitoring our lakes and reservoirs and water quality since the 80s. And obviously, that's manpower, but now in the evolution of hydraulic models and with spatial satellite remote sensing, we've been engaged in kind of this ability to gather data from utilization of satellites for monitoring the water quality in our lakes and reservoirs. And we do this through, spatial analysis, the different technology that uses the remote sensors that detect the difference between, different levels of, the vegetation fluoresces differently, it reacts differently, it bounces back and refracts differently. So those remote sensing rationales help us to identify through collection and data and assessment, the chlorophyll and cyanotoxin risks in our lakes and reservoirs. And we use that data that we collect and we put that into our hydraulic models, and we use our hydraulic models based on our different scenarios that we're undertaking with, refill and draw and replenishment, but to use those to identify how we're going to manage the water supply coming into our treatment plants. We have a multi-spectrum approach where we do a lot of things with tier management. We do lake application of treatment, with copper sulfate treatment. We have the ability to rotate sources. So all of this data really helps us real time kind of identify when we need to maybe do some different actions. So that's definitely helped save a lot of the manpower, because it used to be scuba divers went out, they collected the samples, they came back. It took a lot of time. Now we have this ability to get more real time data and work that into our system. And that also combines with our innovative flavor profile analysis that we utilize on a daily basis. It's still a human touch, but that coupled with the spatial analysis that we're doing really helps us identify the best possible sources and tiers to bring into our systems for treatment.
Great, thank you, Heather. I think you've pretty much outlined one of the key values of digitalization, and that's turning a very manual process into something that's much quicker, much automated in real time as well. We've had a couple of questions come in, so maybe Andrew, if you'd like to, if I can point the first one towards you. It's from Peter Coombs from Innovise. Thanks for the question, Peter. Has anyone monitored the extent of microplastics accumulating on riverbeds? Also, concentrations of prescribed and recreational drugs that are not being fully treated through the wastewater treatment works. Would you be able to perhaps reflect on that question, Andrew, for us?
The state of California has a microplastic monitoring requirement. Right now, they're developing the methods. So we have not done anything yet, but I expect in the next year or so, utilities are going to have to go out there and do some monitoring. Right now, the focus is on developing methods for water, but they're also talking about looking at sediment. So right now, I think developing the methods is where we're at. And once the methods are in place, we'll start.
Great. Thank you, Andrew. We've had a second question come in from Tahira Yasmin, the senior engineer of the City of Brandon, MB. Is there any study on water quality for all of those chemicals have been used due to COVID-19 pandemics? I mean, how is the impact on water quality due to using hand sanitizer, cleaning materials, masks, and other chemical products? Maybe Jan from KWI. I know KWR has been doing a lot of work more on the wastewater-based epidemiology in terms of detecting for COVID in sewage and leading the way on that. But in terms of that question then, the study and research on chemicals resulting from the COVID-19 pandemic.
Yeah, now not specifically on these chemicals from COVID-19 treatment, etc. But we do, as you mentioned, the wastewater-based epidemiology, in which you can find any chemical, any drug residual that is used in the population again, and that also gets you to the needs of the treatment of sewage water, and then, if it is in the sources, and it's inevitable having these rivers through highly industrialized areas, so there is study going on how these chemicals, well, not specifically from COVID-19, but other chemicals as well, medicine residues, etc., how they behave in the existing treatment facilities, which I must warn you is very extensive. There is 15, 16 stages of treatment in this surface water treatment trains even. So, yeah, what happens with these chemicals, and how do they present themselves in the drinking water? So far, we can see that they are removed in the present treatment, but yeah, there is always concern, of course, of popping up in the drinking water in the end of the day, and it doesn't matter in which concentration it is, because the only fact that it is in the drinking water already is disturbing for a lot of customers.
Thank you, Jan. Yeah, it's a good question, and perhaps something that will be looked at in years to come. It's not just also the chemicals from COVID, there's also the single-use masks, the single-use tests, which is a huge worry, and the plastic that comes in. I think all of the knock-on environmental impact of the last couple of years is going to be felt in the months to come. But Heather, you wanted to perhaps comment?
I want to just, if I could add on to what Jan said and kind of address the question a little bit. With Metropolitan and our partner, LA County Sanitation District, we are embarking on a recycled water program, and we have a demonstration plant that we're working on right now that takes, we've taken both secondary, and we're now in the process of taking primary through a demonstration facility with membrane bioreactors, reverse osmosis, and advanced oxidation with UV. And we've actually looked at a lot of these. You could see kind of through the inputs to the wastewater treatment plant, there's been a lot of monitoring that's been worked out with county health departments and state health departments of when you see kind of the spikes that are coming in for some of the COVID positive wastewater sheds that are coming from individuals. So you can kind of see those rise and peaks, kind of get a head start of maybe what is another surge. We do know that those are, removed in primary treatment and so forth, but the carryover, kind of when we're talking about PFAS, other constituents of emerging concern, we have a lot of those that are working through its process. On microplastics, there's been some assessment and studies that are, putting forth sort of a new approach to kind of look at microplastics in wastewater as well. So there's a lot of work that's going on there. And when you get to real-time sensors and monitors, that's something in the new development of the regulations and criteria that the state health department is very interested in. So it's an emerging area, and we're really actively working and incorporating all of these questions that come up and trying to address analytical development and means of, we've enacted a certain way to inactivate COVID-19. So we're not working with active COVID-19 samples, but a way to kind of wash and treat the samples so they're safe for our workers and those working in the labs. But real-time sensors are something that's going to be looked at as a requirement when we're going to put wastewater maybe back into the drinking water distribution system. So stay tuned. There's a lot more, I think, to be had on that topic.
That's a really interesting side to it, isn't it, in terms of interconnecting between completely treated wastewater through to between the wastewater and the clean water side, and actually the use of real-time sensors in that. Fantastic. Well, that we knew it would whiz by. That's got us to the 30-minute mark. So I would encourage people tuning in to continue to ask questions and let the discussion continue to play out on LinkedIn. I want to thank Heather, Andrew, and Jan for your expertise. And it's definitely some areas I think we can continue discussing. As I mentioned, water quality is ultimately one of perhaps the most important areas to water companies, but also a kind of increasing challenge as a result of the impacts of climate change. So we want to thank everyone for tuning in to the QTalks, and also stay tuned for the next edition coming up next month. And please feel free to share the link to the on-demand video among friends and colleagues. Thanks for tuning in.